Hey guys, this is Garrett Wong, also known as Ensign Harry Kim from Star Trek Voyager, and you're watching Astronomy Live.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Stop.
Hi folks, welcome to Astronomy Live. So, tonight I'm going to be streaming the Winged Star on Google Sky. It occasionally makes the rounds on the conspiracy circles as Nibiru, Planet X, or some mysterious object in our solar system. In truth, it's a distant star light years away. But we're going to prove that tonight, using observations I started 5 years ago, actually 5.5 years ago to be exact, and that half of a year is important, because it means we're on the opposite side of the solar system than we were the first night I started taking pictures of this object, back in September of 2015. So, actually I guess I'm not quite right about that, then it's 4.5, not 5.5 years. Close enough. Right now I'm letting the camera warm up. Actually, I just did let the camera warm up, because you can see these little circles in the top left corner of the image. That, unfortunately, is frost starting to form on the CCD. That tells me the CCD chamber is no longer at 0% humidity. This is quite unfortunate, since I just recently changed the desiccant in the CCD. That means the stored extra desiccant that I have is no longer any good. It pulled the humidity out for a couple of weeks, and now it's already dead again. It should last for months, so I'm going to have to get some new desiccant. Unfortunately, that will probably have to wait quite a while. I normally order it off Amazon, and of course, right now it's essential supplies only, and that's not really an essential supply. I may be able to bake the desiccant I have to pull the humidity out of it. It's supposedly reusable, but I don't know how much I trust that. So anyway, these are one of the challenges. This is one of the challenges I'm dealing with tonight, but we'll get through it. So I warmed the camera up to positive temperatures, above freezing, so that pardon the plane going overhead. I don't know how much that's drowning me out on the microphone. So yeah, so the camera is warmed up to 2 degrees Celsius. Normally I run it at least at negative 5 degrees Celsius. And actually in the previous webcast I was at negative 10. And it was running just fine. So even in the span of just a few days, humidity is already starting to be a problem in that CCD chamber, as you can see. So hopefully this new exposure is not affected by that. I'm running Deep Sky Stacker Live, and actually, I should stop monitoring and stop stacking. I don't really... Well, I guess No, I don't want to process them. I should monitor, but I shouldn't start stacking yet. The images. I just want to see the latest image that comes in from the telescope. Now, the star of interest that creates all the hubbub on Google Sky, I believe, is this one right here. In the top left corner you can see a magnified view. You can't see the wings of the star yet, but as I stack more images, hopefully we'll be able to start to see that formation of what look like wings coming off the star. It's actually a nebula associated with the T-Tauri type star that this is. T-Tauri stars often have jets that come out the poles, and they often have some residual nebulosity associated with them. They're young, pre-main sequence stars that haven't entered the main sequence yet and started fusion in their cores. So they're still very hot stars, being young, but they are not full main sequence stars yet. So although they're visible to us, they are oftentimes associated with some residual nebulosity. In this case, that nebulosity takes on the appearance of pair of arcing bows or wings coming from the star, and this fit the description of what many conspiracy theorists were looking for when claiming that a brown dwarf was going to come into the solar system, and there's many claims associated with it, but essentially they claim the ancients saw it as a star with wings. And so when somebody found this on Google Sky, they seized on it. Now, whether through confusion or deliberate misinformation, I don't know, but they also added in another part of the story, saying that this region of sky was previously covered up and hidden by Google Sky. That's not true at all. The right ascension is similar to a region that is missing from Google Sky and is still missing to this day. Well, the new image is in, but I don't see it yet. I guess I have to hit the stack button to actually load up the image. There we go. So now you can see those circles are gone from the top left corner, so I've cured the humidity problem. Well, haven't really cured the humidity problem, but cured the frosting in the image. Now it's going to take a dark frame. I'm going to stop the stacking and restart it once the dark frame subtracts all these hot pixels. All colorful pixels here are just defective pixels on the camera. You can see they are very sharp, just single pixels that are on in red, green, or blue, and the dark frame will take care of that. You can actually start to see the wings, actually, even in just a single image. You can see a little bit of brightness right here near that star. If you're looking in that top left corner, you can see a little bit of nebulosity. These are the wings. They're very, very faint, but they are there. Once we get the dark frame subtracted, that will come out a little more. And of course, as we collect more images, it'll come out more. Now, back 4.5 years ago, in 2015, when I first did this, the conditions of it were such that I was only able to get a short period of time on it. And I didn't have the adaptive optics unit that I now have. So this image should come out even better than what I had back then, hopefully. So in terms of focus, the stars look pretty nice and tight, from what I can tell. I'm pretty happy with things. I think it's just a matter of getting this dark frame subtracted and then start stacking. And we're going to pay close attention in the stacked image to this top left window, this magnified view, looking at the winged star. Some people tried to debunk it by saying it's just a lens flare or some artifact in the image. It's not. It's actually real. It just doesn't happen to be in our solar system. And so the way we can prove that is by looking for parallax. And that's what we're going to be doing tonight. We're actually going to also look for proper motion, or orbital motion. If this were a solar system object, it should be orbiting the sun, it should be moving. But because it's light years away, what we're going to see is it's not really moving relative to the background stars, as far as my telescope can tell. And it also won't exhibit detectable amounts of parallax. If it were a solar system object, if it were within even a couple of light years, it would exhibit quite noticeable amounts of parallax in these images. And of course, if it were approaching Earth, if it were anywhere in the vicinity of the known planets, it would show huge amounts of parallax. So we're going to compare it to the image I took back in September 2015 and see if it moved, whether it moved in terms of proper motion or whether it moved in terms of parallax from Earth's orbital motion. So it's now March, and we're basically on the opposite side of the sun than we were back in September. So that's how we're going to determine whether or not this is a solar system object or a star light years away, as professional astronomers have said. And this is actually a important question here, Sheena Living Waters. Wasn't this the place that Google Sky originally cut out a square to remove it, or is that a rumor? That is misinformation. It's not the same place. there is a spot that is still missing on Google Sky near the constellation Orion, and I've done some deep dive research into that, going so far as to find the original missing negative from that region. See, Google Sky wasn't created by Google setting up telescopes like this and taking pictures of the sky. No, they stitched together pre-existing sky surveys into all-sky mosaics and compressed the images so that they could be streamed easily over the internet. And in the stitching process, artifacts are introduced that weren't there in the original individual photos from these all-sky surveys. And one of these artifacts is just this missing section. But the original image isn't missing. In fact, the original photograph is much larger than the missing section. Most of that photograph is actually visible in Google Sky, but there's a piece of it that's missing. These photographs spanned many degrees of sky each. And we have finally a dark subtracted image. So I'm going to restart the monitoring here. We're going to create a new stacked image, drop all pending images, and start stacking these images from now on. Okay, it probably missed out that last photo because I wasn't monitoring when I started the stacking. Shoot, well, oh well, we'll get the next one. And then we'll actually start the real stack here. With the dark frame removing all these hot pixels. So, the missing section, as I was saying, I've actually located the original negative. I went up to the University of Michigan and took pictures of it. I had it in my hands. And basically I was able to astrometrically solve the picture I took of the original negative and overlay it back onto Google Sky and show that it's just a normal region of the sky. There's nothing abnormal going on there. And while we're waiting, I can go ahead and hopefully share a clip of that video. Going to try anyway. Normally I don't play my own videos in my live streams, so we'll see how this works. And I'm going to try to skip over the beginning because I used some... No, stop! Don't do that. Don't do that. That's what I was afraid of. I don't want to play copyrighted music on my stream. I just had 0.1 seconds of music from the movie Interstellar there, so I'm hoping that Google doesn't detect that. Back when I made this video originally, I didn't have monetization enabled, so it didn't matter. But now I do, so I got to pay attention to these things. So let's see if I can do this.
Florida homeowners, if you have a power meter like this on the side of your house, you can get paid.
Okay, well, there's my own ad. Interact. Stop. Skip ad. And stop. Skip this part. Okay. Here we go. Alright, so I'm going to go ahead and skip forward to the part where I show the photographic negative here. So here it is. This is the actual missing photograph, literally the missing negative, or the negative that contains the portion that's missing from Google Sky.
Look at an original negative of this very picture, the missing section of Google Sky, the blue sensitive film plate. I didn't have a light box to work with, so I made do with the best I had, which was LCD flat panels around, and used that as a pseudo light box to illuminate the negative from behind. Negatives are stored in laminated plastic transparencies. They're not going to let you take them home with you, but if you call them up, you can take a look at them in the library and analyze them however you like. You can see that the photographs are actually negatives. The stars are black spots in the picture. And that's because it is a photographic film negative. You have to invert the colors of the picture to make it a photographic positive. Here's the photograph I took of the missing section of Google Sky from the actual negative. You can see a grid work pattern all over the image. As I said, I didn't have a light box available, so I made best with what I had on hand, which were LCD flat panel computer screens. I pulled up a flat white image on the computer screen and put the negative in front of the computer screen in order to illuminate it from behind. I then inverted the colors and overlaid it back on top of Google Sky, and here's what you see. As my picture of the negative fades in, you can see that the anomaly in the top left fades out. It's not there in the original negative. So therefore, it really is just a scanning artifact. Sorry to tell you, but Google Sky's not actually hiding anything. Although there is something in the DSS images, it's only in the DSS scan of the images. If you go to the actual photographic film negatives, like I did at the University of Michigan, you find out there's nothing there. That concludes this Google Sky mystery. Next time we'll take a look at something which actually is in the photographic film negatives, and see if we can figure out an explanation for what it is.
Okay, so that is that. Now we've got a dark frame subtracted image, so the background light level is a lot lower, so I need to adjust the contrast here so I'm not cutting off the bottom of the histogram. And now the real fun begins, the fun of actually stacking these images. And looking for the so-called wings of this star. I'm just going to take a quick look here at Sky Safari Pro and verify that I am indeed looking at the correct star. Yep, I see the pattern. Yeah, there's really no question. This is the star we're looking for. So we'll see what happens as we stack more photos. This is just a single photo here. And as the telescope takes more pictures, we should improve the clarity. Now, because this particular object is not exactly in season, it does set relatively early in the evening, at least over the trees on my western horizon, so we don't have a whole huge amount of time to be able to get this object, which is why I wanted to get an early start here and get going as quickly as possible on collecting these images. So I'm hoping we have until at least 10 p.m. Eastern Time to gather images for stacking. So in the end, I think we'll have close to an hour of light collected. We had that hiccup there where I had to adjust the temperature of the camera, but I think we'll still end up with at least an hour of light, which would be good. That would be more than what we had back in 2015. What constellation is it? It's a great question. This is in the constellation Taurus. And it's actually relatively close, actually pretty darn close to the Crab Nebula. Let's see, what is the distance to it? So, angular separation is just under 2 degrees from the Crab Nebula. Not too far. 1961, 1988. Yep. And I'm just confirming here with Simbad database that we are looking at the right star. Sure looks like it to me. And also, just a heads up, this image is inverted upside down because of the adaptive optics unit and the mirror that uses to tilt and tip and keep the star centered. So I'm just going to position that magnified window. So the magnified window in the top left shows a close-up of the star we're trying to monitor here. Here comes another image for stacking. Okay, so now we've got 2 images stacked. So it'll take probably quite a few images before we really see some detail here. But yeah, it looks like everything's cooking along well here. The current altitude of the object over the horizon for me is 53 degrees, and it's at an azimuth of 272 degrees, so it's in the west and setting, which again is why I wanted to get an early start here and get as many images as I can before it sets. Thank you, Astro Channel. Yeah, the adaptive optics unit does a fantastic job of keeping things well tracked here. Walmart had toilet paper? Amazing. Everyone in my chat runs out to Walmart right now to buy toilet paper. Yeah, it's pretty crazy out there. I don't have a huge amount, but I've got enough to hold me over for a while, and I'm just going to take it easy, and hopefully it'll start to go back to normal on the toilet paper before I end up needing more. Huh. Oh, and I also realized part of the problem, we've been looking at the latest image, not the stacked image. Let's take a look at the stacked image instead of just looking at the individual images, because this is where hopefully we'll get better quality over time and really start to pull out these dim features. Yeah, I can already tell this one's better. And we're about to get the next image in soon, so we're integrating. We've got 10 minutes of light integrated in this stack, and it'll go up to 15 minutes worth here with this next image. So these first images, you get a lot of return for your investment of time. The noise goes down, the signal-noise ratio improves rapidly at first, and then the improvement is slower over more time, because each image comparatively makes up less of the total integrated time on the stack. So by having 2 images, you double, of course, your time on the stack, your integrated time, but as we get, up to 7, 8, 9 images, each one will only improve it, marginally each time, but give it long enough, it'll make for a nice image. Are those 2 dark dots in the light field due to dust on the optics? Yes, I haven't mentioned that yet, but that is dust on the CCD, actually. Those are taken out by flat field subtraction, but I don't do that here on this part of it. So we get the next image in now. As soon as it downloads into the computer here, there we go, it's stacking. And we should have now an improved picture. So you can really start to see in the stack a little bit of a hint of something coming off the star here. And in this direction too, there's a little bit of a glow. And as we continue to stack more, this should come out more as the wings coming off this star. So we're really paying attention to the window in the top left, the magnified view of the image, where we're zoomed in on this T Tauri star and its associated reflection nebula. Well, at least it's classed in Simbed as a reflection nebula. I suspect it may be more to do with jets coming off the star, but I guess that still counts as a reflection. Yeah, those dust spots are just always there. I think they've always been there. They're in the CCD chamber on the CCD itself, I believe. So cleaning it out would mean opening it up and potentially damaging the seals. You don't want to put that kind of wear and tear on the seals if you don't have to. Especially on this camera, you can't really get spare parts for it. I do have a spare camera, but I don't want to have to scavenge parts off of it unless I absolutely need to. So better to leave it there and just deal with it in the calibration process with a flat field. Fitting a bum gun. I've never heard it referred to it that way. I mean, you can buy a bidet attachment for your toilet. I've got one, to be honest with you, and it will reduce the consumption rate of toilet paper for you quite nicely. But I think the funniest thing I've seen meme-wise on this crisis, in the toilet paper panic in particular, was a picture somebody posted, and it's this black chair with a single sheet of toilet paper sitting on it, and it says, I thought my most valuable investment was my house, but now it's this. So it's crazy. Most of the time lapse is taken during the day. Yeah, you will get dust visible in daytime shots as well, though, yeah, it probably does look different with the blue sky in the background. Yeah, and the other thing about that's a great point, Sam, about the path of the optics and the shape of the optics. So they look like miniature donuts, because that's actually what the shape of the optics are, essentially. It's a giant donut. It's a mirror with a hole in the middle. because this is a catadioptric telescope. So that's reflected both in terms of out-of-focus stars and even out-of-focus dust that's on the CCD. That dust isn't quite at the focal plane. It's sitting, on the CCD above where the light is coming to focus. And so, as a result, it does take on the shape of the circle of confusion, which is the shape of the optics. And so you can see the donut shape in the dust as well. You can actually see the same shape of dust in a lot of the tracking shots of rocket launches, especially if you look back at older film footage, the Apollo missions, even shuttle missions sometimes. You can see when they use the really high-powered optics to get a close-up of the rocket, you'll oftentimes see donuts sitting in the sky. If you look away from the rocket in the blue sky, you can see some donuts around in some cases. And that's because oftentimes they are using a catadioptric optic to follow the rocket, to track the rocket and film it up close. So the collaboration I'm doing with Tim Dodd, the everyday astronaut, to film rocket launches with a off-the-shelf catadioptric telescope is not actually too far off the mark from what professionals use down at the Cape. They basically use giant telescopes that are on really fast tracking mounts that can keep up with the rocket. Okay, so we've got another image in. So yeah, as we collect more images, the quality should continue to improve, and we should continue to see a little more definition in these wings coming off the star. You can see where my mouse cursor is. That's where the star is in the overall image. And then I'm going to Alt-Tab out. And that will leave the high magnification view in the top left. I've kind of positioned it a little off-center from the star, hopefully to capture more of the wings as the photo develops. The stacking program is Deep Sky Stacker Live. Was it in the latest month's S&T? I haven't cracked it open yet. They've got an Orion Bino viewer. Sounds cool. I don't do enough visual astronomy anymore, though, to get my money's worth out of it. My eyepieces only ever get used when I'm either setting up or for a few minutes when I'm tearing down and I want to look at a planet or something. But when it comes to deep sky objects, I'm all in on astrophotography pretty much, even for the planets for the most part. Now, yeah, Bino viewers, and they are useful. I've used Bino viewers with DSOs, but I think a lot of people probably think of them in terms of lunar planetary use. What's the NGC? It doesn't have an NGC designation, actually. It's a great question. You can find it on the SIMBAD database, listed as GN, so that's G as in galaxy, N as in nebula, 05.39.2. I'll put that in the chat. And there's another designation for it, I believe, and I've forgotten what it is, but it's not. I don't think it's listed on SIMBAD. The central star that's associated with it, the star itself, has multiple designations. One of which is, I believe this is a TICO designation, TYC 1861-1988-1. So that's TYC 1861-1988-1. and that's the actual star itself. The nebula is technically GN0539.2, GN05.39.2, but the star has a separate designation. Oh, it consumes no back focus. Oh, it's the May issue, okay. Well, that's impressive that it consumes no back focus. With a Schmidt-Cassegrain like this, though, they usually do have pretty generous back focus capability. For those who don't know, Newtonian reflectors designs usually don't have as much travel on back focus as, say, a Schmidt-Cassegrain or a Maksutov-Cassegrain. So I think I've only ever used bino viewers with SCTs for that reason. But that's cool. If it's got no issues with back focus, a lot of the guys who own these big Dobbs will probably get a lot of fun out of that. Yeah, Venus is super bright. I took a look at Venus earlier tonight when I was aligning the telescope. It looks like it's a little less than half full now. Waning. Yeah, works on any telescope. That's cool. Yeah, if you ever go to one of these major star parties like Chiefland or the Keys, the winter, like I guess they just call it generically the winter star party, you can see a lot of guys who have these really gigantic Dobsonian telescopes, and oftentimes, you know, they're on tracking mounts, but they're essentially out as aligned. They're not really set up for long exposure, deep sky work like this. They don't need to be, though, because they're so massive. The apertures are so large that they can do electronically assisted video astronomy, where you have a sensitive video camera that basically produces the images very quickly, and it can do in a few seconds what it takes my telescope, you know, half an hour or an hour to do with this camera. Perhaps at the expense of video resolution. They oftentimes trade off resolution for sensitivity. But even that, I think nowadays the sensors are getting so good that that may not actually be as true as it was before. And so, yeah, these guys, most of them, throughout most of the night, will be using, you know, these eyepieces and just looking through the telescope and seeing the Veil Nebula, seeing these really faint nebula that you couldn't see at my telescope. You just couldn't with an eyepiece. And it's really great to see. It's really fun to look through these big scopes. They're usually very generous with sharing the view. If you see a guy like me hunched over an SCT with a laptop monitor, we may be more preoccupied with trying to fix some issue with our CCDs or something. I mean, we may share the view, but it's not quite the same when you're looking at a screen than when you're looking at the eyepiece and just taking in the light. Ooh. Yeah, one of the club members has an 18-inch. Yeah, that's a very popular size. And you have a club telescope, a 30-inch fork-mounted Newtonian. Holy cow, that's bigger than the telescope that we had at the observatory when I was in college. So, that's awesome. Thoughts on upcoming meteor storms. I haven't paid enough attention lately to upcoming meteor shower predictions. Is there a prediction of an upcoming meteor storm? I probably should know these things, but really haven't had the time to keep my finger on the pulse of all that. Oh, they didn't predict Atlas to get here till end of May, so it's 2 months early. So now your projection, major meteor showers. Well, I will do a video all about Comet Atlas's orbit. It's getting brighter faster than expected, but the position is where the orbit predicted it would be. It's not out of position. It's not like it's ahead of where it should be in its orbit. And its orbit doesn't get that close to Earth's orbit, nor will the comet get all that close to Earth. So, because the orbit of the comet does not intersect the orbit of Earth, it will not produce meteor showers here on Earth. Meteor showers are normally produced when we fly through the path that a comet previously took. That's the most common source. So yes, if Atlas were to intersect our orbit, even if it didn't collide with the planet, it could leave behind meteor debris that we would then potentially experience as a meteor shower or even a meteor storm. But in this case, the intersection distance is way too high for that, so that won't be happening. But I can do a video about that, and actually we can use the images that I've collected over the last 2 webcasts of Comet Atlas to calculate the orbit independently. Interestingly, the orbit is very similar to the Great Comet of 1844, I believe. Comet C 1844Y1, I think it was. I might be a year off on that, but I think it was 1844. And the orbit of that comet was extremely similar to this one, so they probably are related objects, though they're not the same object. So, up here comes another picture. I want to see what happens when it stacks. How much is it changing? Really don't see much changing there. I wonder if this is not actually showing me... I don't know. I guess it's just that we're now to 6 images stacked, so each image contributes less overall. Check my settings. I think we may be getting some extension there on this side of the wing. Hard to say. It could be noise. We'll know more once we get more images stacked here. I'll try to position that window so we can kind of monitor that. Oh, thank you, Shadowburn. Yeah, you were around during the Comet ISON days. Oh, those were hysterical days, weren't they? And not in the good way. Alright, have fun at your scientific conference and, you know, stay safe. Don't get too close to people. Yeah, I remember seeing Shadowburn around over the years. I think we've got a lot of new subscribers lately. I know Tim Dodds promoted my channel a bit here and there, and even showed up one night a couple webcasts ago and tweeted it out. So if you're new here, consider subscribing if you haven't already, and hit that bell for notifications. I was able to schedule this stream pretty well in advance, about 12 hours in advance, so I'm going to try to do a better job in the future of scheduling these things far enough in advance that people can get notifications and know when I'm going to stream. I kind of have to play it by ear, of course, because it's always weather dependent. And I'm really hesitant to go ahead and schedule a stream based on a forecast that's 2 or 3 days out, because it can and will change, and I really hate it when I have to cancel a stream due to weather. I feel bad if I'm getting people, worked up, or people are planning to watch something and then I yank it out from under them. I hate doing that. So I don't like to schedule a stream until I'm really sure I can do it. But you have to balance that against the fact that if I just impromptu throw a stream up, then fewer people are going to show up because nobody knew it was going to happen. So I saw the forecast today. It was showing severe clear all through the evening and even through the day. And I went ahead and scheduled the stream, and then throughout the day it was cloudy. I'm thinking, boy, I don't know. So even though the forecast said today should be clear, it was pretty cloudy until sunset, and then it all cleared up very nicely, and so we're good to go. But yeah, it's oftentimes a challenge trying to anticipate what the weather's going to do. Thank you, Anstey. What part of the sky is the comet in? Well, this isn't the comet. We're looking at a distant star here tonight, and we're going to take a look at its parallax, comparing it to observations I made almost 5 years ago. The comet is still in the north. It's, I don't know if it's still in Ursa Major. It should still be near Ursa Major at the very least. It's probably still in Ursa Major. Let me take a look. Atlas, yeah, it's still in Ursa Major. Declination is positive 68 degrees. So it's even slightly higher in declination than it was when I last observed it. This right here, though, yes, this is in Taurus. Pretty close to less than 2 degrees from the Crab Nebula, actually. Did I capture the Atlas rocket launch? No, definitely not. Yeah, sorry, I had to work today, so I couldn't go to the Cape. Even if I could go to the Cape, I don't think I could really film it. The public viewing area just outside the gate to the base was closed due to coronavirus. Oh, I said the word demonetized. Hopefully not. And I can get on base, but I don't know that they had the on-base viewing locations that are normally open this time. So yeah, I didn't want to risk that anyway, even if I didn't have to work. So kind of waiting to see what goes on, and hopefully next time we get a weekend launch or a launch I can attend at night or something. Hopefully I can find a spot to watch it from. It's pretty wild. I think her name's Julie Bergeron on Twitter. Go check her stuff out. She basically documents a lot of the SpaceX ships going in and out of port, and a lot of the stuff going on there out at the Cape, these launches and such. And she posted a picture of the traffic in the area right after the launch. It was surreal because there's nobody. Normally the roads are jammed with tourists right after a launch, but not this time. I think word is out that people should be keeping distance from each other, which is good. But unfortunately, it has a negative impact on our ability to get footage of launches. as you may know, Red's Rhetoric did not go to this launch specifically for that reason. So, like I said, I can get on base, and I can get to isolated areas where there's nobody else around. So that may be a possibility in the future. But I definitely wouldn't set up in an area where it's publicly accessible and there are likely to be other people mingling around. What time is Mike Around the World and Paul Begley on tonight? I have no idea. Man, Paul Begley. There's something else that goes back to ISON days, Comet ISON. He was saying that was a 3-piece spaceship or something. And I was showing that was actually due to parallax from Hubble's orbit around the Earth. And here we are again tonight, measuring parallax. Where this image is the winged star. Ah, you mean in the overall image. So we're looking at a close-up of it in the top left corner. So up in the top left corner, this window, well, okay, now the window moved, but in the top left corner, you can see a magnified view of it. And where you can see the mouse cursor here, near the center of the image, this is the winged star that we're watching. So we're developing this photo by stacking more and more pictures on it to be able to bring out the detail. So I hope that answers your question there. And 2 pounds from SlickX to make up for the virus. Thank you. Appreciate it. So I'm just looking at the position of the telescope. We've got another stacked picture in there, starting to improve the image a bit. It'd be cool if I could subtract flat fields from this to be able to improve this. The vignetting, this looking through a straw effect. This will also be taken out by flat field subtraction. I'm not really sure where the tightest bottleneck is in the optical train that causes that. In this case, the camera's directly bolted to the adaptive optics unit. I have a feeling that unit itself is the cause of that. I know this particular adaptive optics unit is not compatible with any larger cameras that have larger CCDs, and I think that's why. It's really only intended for cameras of this size, and even this, it's kind of a choke point. But with a flat field subtraction, you can get rid of that. I'm just wondering if I tweak the contrast. Okay, not that much. Back a bit. Okay, too much. It's real tricky. I can use the arrow keys, but it's a little bit coarse. Just trying to improve the contrast on it a bit. You can kind of see it there. It's faint, but it's there. This little faint nebulosity coming off here and here on the star. Just take a look at the latest image. So the other thing we'll be dealing with just as it gets lower in the sky is there will be more just background light from just sky glow, and it is setting in the west. The west isn't so bad for light pollution per se, but to the north, even in the northwest, you kind of get a light dome. So that may start to intrude a little bit, but hopefully not too much. But it's coming along nicely. 8 images stacked so far. You can see the stack total up at the top of the screen. And, yeah, that's how we're going to go. So I'll leave that there. Here we go. Oh, and a super chat from Ants D, £5. I didn't know I could do this, so again, thanks very much. You're welcome, absolutely. Looks like it has wings. Is it outgassing? Well, these wings, I have to look at the research articles again. They may actually be related to jets coming from the star, but these stars are young pre-main sequence stars. This is a T-Tauri type star. And so residual nebulosity being around the star is not unusual for these types of stars. There's another good example of this called Parsemion 21. I've taken pictures of that before too, and it also kind of has the appearance of having wings and a very similar morphology to this star here. So this is not out of the question, or it's not unprecedented with this type of star. Scariest thing in the skies is... What is that noise? Oh, somebody's car alarm? Oh, somebody shut it off. Okay, good. Scariest thing in the skies is Comet C-2019 Y4 Atlas at the moment. Well, it shouldn't be scary. Like I said earlier, the orbit of that comet does not intersect Earth's orbit. And the closest intersect distance is, I believe, over half the distance to the Sun. In addition, the comet itself will be even further from us at its closest point, a little further than 3/4 the distance to the Sun away. So there's no risk at all of impact from that comet, and we're not even going to fly through whatever it leaves behind. So it won't generate any meteor storms or meteor showers. So there's really no risk to Earth from that comet. Yeah, the coincidence of the comet flying by and the outbreak at the same time. I mean, you know, these were the kinds of coincidences that did happen occasionally in antiquity, and people took comets as ill omens at that time. But then again, in antiquity, plagues were not all that uncommon, and neither are comets. If you want a great example of just how many comets were observed in antiquity, you can take a look at Gary Krunk's Cometography series of books, and there's multiple volumes to these books covering all the way through recorded history, essentially, where he's solved for the orbits of these comets, or published them anyway, and gives references for where the observations of these comets come from. Of course, as you go further and further back through history, the orbits are more and more approximate, and oftentimes based on observations of Chinese astronomers who kept good records of these things and where the comets appeared, and what constellation in what month. And so by tracking that, you get a rough idea, a very rough idea of the comet's orbit. And yeah, it's rather amazing to see how, to me at least, like, I was shocked when I first opened up these volumes and seeing how big they are. Just the ancient history one is this full volume that goes up to somewhat more recent times, and there's just comet after comet after comet. And even now, Atlas is not the only comet out there right now. It just happens to be the brightest. I believe it's the brightest. And there's oftentimes many other faint comets. At any given moment, there's multiple faint comets out there that you need a telescope to see, and they don't even look that impressive. Atlas is unique because it is related to a great comet from 1844, and is already starting to brighten up even faster than anticipated, so it has the potential to put on a very good show. So we'll continue monitoring that comet, and I'll continue to do webcasts of it in the future, provided the weather allows. The weather's good tonight, and it's been good over several nights this past week or so, which is why I've been able to do all these webcasts. But as we get closer to summer, unfortunately, in Florida, the weather will deteriorate. But right now, it's still good. It sounds like a lot of traffic in Florida. Unfortunately, my microphone right now is kind of pointed back towards the direction of the interstate, which I'm not too far from, which is why you're hearing all that traffic. And then somebody's car alarm was going off in the neighborhood, but fortunately that's done. Is there anything we could actually do if a comet that size was on a collision course? People suggest missiles, but that wouldn't avoid an actual impact, right? Well, it all depends on how big it is physically, and how much time we have ahead of its arrival. Unfortunately, with long period comets, the answer is usually not a whole lot of time, and if it's a major comet, the size can be quite large, too large to deflect with missiles. So yeah, in reality, if you had a really large object coming towards Earth, something that would wipe everything out, with less than a year warning, as a comet might give us, maybe a year at best, for a speedy, long period comet, no, we wouldn't really be able to do anything about it, to be honest. I mean, you look at Comet Atlas, for example. It was only discovered late in last year, so we basically had less than a year of knowledge of its existence between the time we discovered it and the time it will reach its closest approach to Earth. Fortunately, that closest approach to Earth is not an impact or anything even close to one. But when it comes to large comets like that, assuming Atlas has a large physical nucleus, I don't actually know that it does, but something that is kilometers in size, then there's not a whole lot we could do with that little warning, because the more warning you have, the less you need to adjust its orbit to avoid a collision. You can give it a smaller nudge to push it off course so that it doesn't collide with Earth. But if you don't have a whole lot of warning, you need to give it a lot more velocity to push it off a collision course. And we just don't have the means to do that, really, for something that's really big. It's like the movie Armageddon is absolutely ridiculous. And there's actually a pretty good video I saw this week from, I forget who made the video, but it's got Chris Hadfield in it, former commander of the space station, Canadian astronaut, and he was talking about various movies he's seen and mostly what he hates about them, about these space movies. And I have to say I agree with his assessments, and he despises the movie Armageddon for its scientific inaccuracy. And I remember back in the day I annoyed my friends too with lamenting how ridiculous it was, whereas my friends just thought it was a fun action film. But in the movie they talk about this, I think they call it an asteroid, but it looks more like a comet coming towards Earth, being the size of Texas. I'm sorry, you're not going to be able to do anything about something the size of Texas coming towards Earth. In fact, if memory serves, that's larger than Ceres. Assuming Texas is supposed to be the size of its diameter, that's really big. And supposedly this was an asteroid that suddenly got knocked towards Earth, I guess. Like, we would have known about something that size. That's the advantage, though. If it were just an asteroid, something that size, we'd already know about it. But smaller objects that can cause regional devastation, those can slip by us and leave us with no warning before impact. And, we're gradually trying to improve our detection systems, our warning systems, to be able to detect smaller and smaller objects. For really small objects, you can't detect them unless they're already close to Earth. So you have to find them on an orbit that is hopefully years before they actually arrive, where you can track them and figure out their orbits before they're actually on their final orbit where they're going to collide with Earth. So, the way it's often portrayed in movies is fantasy, where they find something and then they scramble, and in a couple weeks or a month, they've got a mission going to try to deflect the asteroid, comet, whatever it is. And in reality, it would require much more time to prepare, and hopefully the idea of a real deflection would be that you would detect it years before it's going to collide, and you would then have time to plan and mount a mission to deal with it. So, anyway, that's the lengthy answer on that. Alright, I'm going to let this telescope continue collecting images for a bit. I'm going to some stellar drones, so enjoy the tunes. And we'll continue to watch the winged star develop in the top left corner. So, I just took a break there to grab a bite to eat. But I'm back now. So, I'm going to try to adjust the contrast. And I apologize, I realize now my mouse cursor on my screen is not where you guys are seeing it on the screen that's actually being shared. There's some glitch going on, so the mouse cursor is not actually pointing at the right star when I try to manually point it out, but it is showing it in the top left corner when I point at it, which is weird. So something strange going on there with screen sharing Deep Sky Stacker live, but not a huge deal, just something I need to be aware of. Yeah, that didn't work. Okay, so that's as good as it gets, unfortunately, on the contrast. At least doing this live, that's as good as it gets. But yeah, I can actually see that the wing extends from the star, and then it comes down this way. It comes to a point about here, I think. It's quite large. The other wing is not as big. It's kind of stubby by comparison. Really wish I could point it on the main screen. It's just to the right of center. You can see it on the main screen if you look carefully. One of the stars just to the right of center has a bit of an arm coming off of it, and that's that long wing on the left side. And then in the zoomed in window you can see the other wing pretty easily there, kind of stubby, hanging off the bottom of the star. So the thing I want to do, if I can, is try to do some astrometry. Oops, didn't mean to do that. Okay. Oh, huh. Alright, so I guess it's going to take away the zoomed in window, even if I'm giving focus to a different window, like Chrome. So you'll have to, sorry, we'll just have to live without that for a moment. I'm going to see if astrometry.net's website is working right now. Sometimes they have issues. So I'm going to try to upload the stacked image here and see if it will solve. Oh, I need to actually make sure I save. Can't. Settings tab, just like stacked image output folder. Oh, output folder. Here we go. Okay. Stacked image. I did select it. Each 10 images. Okay, so every 10 images it saves. Sure, whatever, I guess. I can manually tell it to save now. Or not. What is your problem? What is your major malfunction? Okay, so that did not work. Alright. If it wants to do that, then we'll just deal with that. So, I'm just gonna have to load up regular Deep Sky Stacker. Oh no, oh no. I loaded another copy of Deep Sky Stacker Live. I didn't mean to do that. Okay, good, it didn't mess anything up. I just want regular Deep Sky Stacker. So I think at least it will remember the registration information for these photos, meaning it hopefully won't have to realign or figure out where the stars are in the photos. It should already know pretty well, it seems. Okay. And I'm gonna try something that never ever works, but I'm gonna try and feed it the flat fields from my last webcast, because the telescope was pretty much in the same configuration. Man. Lots of planes going over tonight. Okay. Oh, it's gonna have to download those. Okay. Okay. Flat field. Add those as flats. Stack them. Okay. Save the output as fits. Go for it. Man, this computer's fast. I love it. It's my new laptop here. It's pretty spiffy. Okay, so it's stacked them. Now I'm gonna upload that to astrometry.net. Take a bit. We'll see if astrometry.net is actually working properly tonight. Still uploading. It's a big file. Okay. It's uploaded. Let's see if astrometry.net processes it. If not, I can just take it to my desktop and process it in Linux. Which, in all likelihood, I should probably do anyway. But download. So I'm also going to download the stacked image I took in September of 2015. I'm just going to move that into the same directory. Oh, no, I shouldn't move it into the same directory. It'll stack it. I'm going to just move it into a different, slightly different directory. Okay, move it there. And then I can upload that to astrometry.net as well, so that we can compare the position from them. Okay. Hopefully astrometry.net processes it. If not, we'll just do this on the desktop. It would just be more convenient to have it here on the web. But it's not pulling the sources. It did this to me the other day. Astrometry.net would let me upload photos, but it would never actually start the processing. Oh, hey, it started the processing. Okay, good. Also, I didn't actually check to see if that flat field subtraction that I did was reasonable or not. I should have checked that. Oops. Okay, let's see if I can just check and see, does it look like absolute crud, or does it look decent? Well, it looks decent, actually. Just reusing the old flats, it's not actually too bad. So let's see, we have success on that one, and we're still waiting for processing to start on the one from 2015. But at least the current one, yes, it's working. Okay, cool. The one from 2015 solved as well. And then this was September 9th, 2015 was the old one. So I'm going to save that. So I'm saving the astrometrically solved FITS files from astrometry.net. I might need to grab SAO image DS9 off my other computers. Why won't that window stay up? Okay, Okay, for some reason it's not responding. That's peculiar. Let's just check on how this is doing. Oh, this is doing nice. This is doing quite nice. Yeah, you can really start to see these wings coming off this star here. Oh. What have I done? Why does it suddenly say the total exposure time is 3 hours 40 minutes? I hope this thing didn't accidentally stack the photo from 2015 onto it. I didn't mean to do that if I did. I don't know why suddenly the exposure time up here says 3 hours 40 minutes. It's not been that long. Peculiar. Okay. I don't know what happened there. Oh, I know what it is. I know what it is. I did it. I did a thing. I did a wrong thing. It double stacked everything. That's annoying. Okay. Because I stacked these images, it generated an autosave version of the stack in the directory that I'm collecting all these images in, and Deep Sky Stacker Live will just happily grab that and throw it on top of the stack, so it just doubled everything. But it doesn't actually give you any new information. It doesn't make the image better. It just dilutes the signal of the other images coming in now. That's unfortunate. I can fix it. I can fix it. If my File Explorer would please not crash, that would be great. Come on, Windows. You can do it. Do I want to save modifications? No. Come on. Come on, File Explorer. File Explorer is crashing. Okay, that's cool. Hopefully they didn't crash the stream just now. Doesn't look like it did. Yeah, File Explorer just completely crashed out. That's not ideal. Okay, I'm gonna have to... I'm just going to grab everything out of this directory, throw it in a subdirectory. Okay, and now Deep Sky Stacker Live, I'm going to stop it. I'm going to monitor with a whole new image, drop all pending images, clear out the stack, and then I'm going to throw the images back in. Should be in there, and it's just going to restack everything. So now it's stacking them. Now you can watch this process play out in real time. So in the top left we have the winged star. You can see what's happening as it's adding each image. So it's stacked 10 of them, and that noise is going to go down as it continues to stack them. So this is just getting us back on track, where I don't have the stack basically duplicated. Yeah, I remember when Explorer died and the taskbar disappeared. I remember those days. Okay, now we're right at 2 hours on the money for images. Let's see what the latest image looks like. It's pretty bright, so we're getting down low. I don't know how much more light we're going to be able to collect on this, but we've got enough to go with for sure. So, alright. While that is happily back on track, I'm going to go grab SAO Image DS9 and get ready to analyze the stacked pictures from tonight and from 2015. So, I'll be right back. So those wonderful Windows sound effects are the sound of me plugging in my USB drive with SAO Image DS9 on it, which I will now transfer to this computer. This allows us to look at the astrometrically solved FITS files and do things like get the coordinates of any position in the image and compare it to coordinates in another image. So we can see if there's any something just leaped on my porch. I think there's a frog over there. So we can see if there's any parallax. Okay. So I'm going to get these images loaded up, and then I'll share the window for SAO Image DS9. So, because I did not have the adaptive optics unit back in 2015, the camera has a slightly different image scale than it did 5 years ago. The apparent magnification is not the same. But that's okay, because with astrometry, we can get the exact coordinates throughout the image. Let's go back to the previous frame. So I'm just trying to get things adjusted so that... Oops, I didn't mean to do that. Just trying to get things adjusted so we can see what we're looking at here with the star. Also, because I didn't have the adaptive optics in 2015, another consequence of that is that the image is mirrored this time compared to how it looked in 2015. Yeah, that 2015 image is not nearly as good as what I've got tonight. But that's okay, we can see the position, and that is the main thing. So let's go to log. Alright, so let's see, let's go to the next frame. Sorry, I'm still trying to get the histogram figured out. Alright, I'm going to go ahead and share the screen now. Hopefully this works. Okay, cool. So here's SAO image DS9, and you can see this is the image from 2015, from September 2015, and looking at the winged star, SAO image DS9 only lets me see an individual color channel at a time, so I can't see it in color, but you can see the wings. In the top right corner there's a zoomed in box, so you can see the wings coming off the star here. They don't look as extended in this photo because I didn't have as many individual frames to stack back then. And so I'm going to go ahead and hang on one second. I'm going to save those. I'm going to save the region I just created there. So that's that green circle. I'm going to save that. And we're going to save it as WCS. So WCS is World Coordinate System. So the coordinates are now embedded in the image thanks to astrometry.net. So if on the top left, you should be able to see it there. Yeah, you can see the coordinates when I mouse over it. You can see the coordinates. Now my mouse cursor is probably not in the right position, so ignore where the mouse cursor is. But you can see the coordinates for the green circle in the top left there. So I've saved those. And now I'm going to open them up in the other frame. So if I go to the next frame, this is tonight's image. This is a partial stack of the images from tonight. It's noisy, it's grainy because we're only looking at a single color channel here, but you can see the wings coming up off the star in that top right image, zoomed in. So now I'm going to load the regions, and we're going to find out, is it moving? Load it into current frame. Boom. It's still exactly in the same position. So you see in the top right corner again, zoomed in, there's that green circle. It's still circling the same star. The same star hasn't moved. GNO-539-2 is in exactly the same position as it was 5 years ago, as far as my telescope can tell. It can tell no difference. There's no shift in its position due to parallax visible to my telescope. If this were anywhere in the solar system, it definitely would. The pixel scale here is about 1.2 arc seconds per pixel. An arc second is 1/3600th of a degree. So again, if I go back to the previous frame, GN-039-2, that green circle is perfectly circling, as you can see in the top right zoomed in view, especially, you can see that green circle is perfectly centered over the star at the center of this object. And if I go to the next frame, it's still, if you look at that zoomed in view, it's still centered around that star. It hasn't shifted position. Now there is another star nearby that does exhibit proper motion, because it is relatively close to us compared to GNO-539-2. I don't know that it exhibits noticeable parallax necessarily, but it does exhibit proper motion. I'm going to see if I can find it here. And actually, frame, you know what we can do? Yes, we can align on WCS, can't we? Let's see, where is it? Align WCS. Align. Okay. Frame, previous frame, zoom, align, WCS. Okay, frame, next frame. Okay, so if you have issues with blinking images, you might want to look away here for a second. I'm going to blink these images rapidly between each other. hard to say because the scales are different, as you can see. Tonight's image is a little more zoomed out than the other one. Okay, stop blinking frames for a second. Single frame. Let me zoom out a little. Oops. No, I need to pan to be... That. Okay. Zoom up. Trying to do this with the touchpad is not fun. Zoom rotate parameters. Oh, that's interesting. Wish I could specify certain angular size in the zoom, since this image is astrometrically solved, but I guess I can't do that. Okay. Let me try looking something up here real quick. Okay. I think I see it now. Frame. Next frame, yeah. Okay. Oh, no! I don't mean to pan away from it. And we're getting real weak on the autoguide star. My telescope's still taking pictures even now, but I don't know how many more I'm going to get. Okay, yeah, it's hard to see because the zoom keeps changing. But that is what astrometry's for. So instead of a pan tool, how do I do this? I want pointer. This star right here, okay? So this is its position in the image from 5 years ago. Or almost 5 years ago. Okay. Region, get information. Let's change this radius of the circle to be 5 pixels instead. So it's nice and tight around that. Coordinate WCS. Oh no. Come back. I'm just going to title this as proper motion. I don't recall the designation of this high proper motion star. I used to know, but I've since forgotten. So we're going to do that. We're going to save that region. Okay. Save it in WCS. Yes. Okay, frame. Next frame. So coming to tonight's image. I'm going to clear this out because it's otherwise going to get duplicated. I'm going to load the regions again. Into the current frame. So, if we go here, you can see it's not quite centered. It's a little offset because of the proper motion of that star over the last 5 years. So we can see a star gradually moving. We can see, we have a positive control, as it were. We can see the motion of a star over even just 5 years. But if this were a solar system object, it should be moving a whole lot more. and yet the green circle is still perfectly around GNO 539-2, or the central star, which I believe the designation again of that central star to this object is, what is it, TYC 1861-1988-1. So there you go, guys. It's not in the solar system. It is light years away. These images are almost exactly 6 months apart, a few weeks off, but not by much. So we should be seeing maximum amounts of parallax here, and we just don't. So going back to the stacked image, which has still been collecting more images. We're now up to 2 hours and 25 minutes of total integration on it. It's pretty good. So you can see the wings coming off the star there in the top left. That box might go away here in a second. So I'm going to look up something real quick. And that's probably going to goof up. Yeah, that goofed up the box. That's fine. So tonight's image has a little less magnification by 0.07 arcseconds per pixel. It has a pixel scale of 1.24 arcseconds per pixel, according to astrometry.net. Okay, so if we were to see 1 pixel of parallax, okay, this calculator doesn't look so good. Okay, so I'll find a good diagram of it here. Actually, this isn't so bad. Let's see if I can share this on the stream. So, here's a little diagram of parallax for you. Parallax made simple. So, Earth's orbit around the Sun has a radius, as you can see, of 1 astronomical unit. And you may have heard the term parsec. Unfortunately, most people have heard it used incorrectly in Star Wars, but it's actually a measure of distance. And 1 parsec is equivalent to the distance of a star that exhibits a parallax of 1 second of arc, 1 arc second, with that radius of 2. So with 1 AU of displacement and position exhibiting 1 arc second of parallax with a 1 AU baseline. Well, we actually have a 2 AU baseline because we're on the opposite side of the sun. So it's the diameter of Earth's orbit that matters here, not the radius. And so the baseline is actually twice what it shows in this diagram. But we can divide the angle in half, or conversely, we can say, okay, 1.24 arc seconds is our resolution, 1.24 arc seconds per pixel, but we actually have a 2 AU baseline, and so it's roughly equivalent to seeing a 0.62 arc second displacement with a 1 AU baseline. Okay, so that is, in other words, the failure to see parallax here in GNO 539.2 means it is more than a parsec away. In fact, 1 divided by 0.62 is equivalent to 1.6 parsecs, which is equivalent to light years, 5.26 light years. So that means this object has to be at least greater than 5.26 light years away. Of course, it's probably much further away than that, but just from the angular resolution of these images, we can say it is more distant than that. It is not in our solar system. Pretty cool, huh? Its actual distance, I don't know. It's pretty far away. It's not anywhere in the neighborhood for sure. Oh yeah, that zoomed in. Sorry, I forgot the zoomed in box in the top right of SAOH DS9 was probably cut off a bit. It didn't really matter all that much, I guess, but we can go back to that here real quick and just take another look at that. I can try to resize this. It might get a little glitchy on the edges here because it just will be, but okay, there you go. Now that box isn't chopped off, so let's just take one more look here at SAOH DS9 where I'm not chopping off the box. So here on the top right image you can see GNO 539.2 zoomed in, and how that green circle, this is the astrometry based on its position from 5 years ago. In 2015, when I took this picture in September, well, the other picture in September, and I did the astrometry, I placed a circle directly over it, and then saved the coordinates of that, and loaded it into the current image. And it still overlaps that star perfectly. Whereas the other high proper motion star, which is a little just off to the side of our winged star, this does exhibit proper motion over time. I've seen it compared. I've compared my image from 2015 to images that were taken decades earlier at the Palomar in the Palomar Sky Survey, and there's very obvious motion of this star. And even now, with just 5 years difference between the first picture I took 5 years ago and tonight, you can see that green circle no longer perfectly lines up with that star. It's just offset to the side a little bit. And if I go back to the previous frame, the frame from 5 years ago, you can see that proper motion star, that green circle goes right around it. So it has moved. And GNO 539.2 has not. So there's no parallax there in GNO 539.2, but there is in this other unrelated star. So that tells us GNO 539.2 is far away. It is more than 5 light years. and we would see motion if it were actually moving or if it were actually exhibiting parallax. So, I think that all makes sense. And we are reaching the very limit of what I can get with images of GNO 539-2 tonight. I'm going to go ahead and abort the autoguider. It's almost... The autoguide star is almost too dim for the autoguider to pick up at this point because we're pointing so low. We're going to be hitting the trees soon if we haven't started hitting them already. So I'm done collecting images now. But we collected 2 hours, 35 minutes of light. That's way better than I thought. So what I'm going to do now is I will stack these images properly in Deep Sky Stacker proper. And do tone map, HDR tone map of the image. And distribute that. I'll put that in the video description when it's done. That'll probably be done sometime tomorrow. And then you guys can get a high-quality, high-resolution picture of this winged star that was on Google Sky. Still on Google Sky. But not in the hidden region, as we talked about earlier. Totally unrelated to that. And it is definitely not in our solar system. It is definitely more than 5 light years away, as we found out tonight by looking for parallax. So, any final questions in the chat? A flat earther who thinks it's unfortunate that I'm being accused of faking my SpaceX landing footage. Thank you. Appreciate the honesty and the candidness there. Really appreciate that. Just heard a Dodge in the background. I don't know what it is with the interstate tonight. I have a hypothesis that people are suspecting the cops aren't going to pull them over because, you know, the thing that's going around. And so they're cutting loose on the interstate with the anticipation of not getting pulled over. I don't know. I could be wrong in my assumption there, but that's what it sounds like. I keep hearing really fast cars and motorcycles whizzing by on the interstate tonight. Glad I'm not driving. All right. Thanks, Fish. Thanks for coming. So yeah, that's pretty much all there is to it. I think we did a bang-up job tonight getting images of this winged star. I know it doesn't look like a whole lot here, but this isn't fully processed. This is just stacked, and we can already see it. And when I do some flat field subtraction to even out the frame and do some more contrast on it, tone map it, it'll probably pop out real nice. So stay tuned for that. Come check back tomorrow sometime. Should have it done by tomorrow night. The stack of the image. Also, I'm going to be on with the shills tomorrow night, so check that out. Dick Dawson should have... I think he should probably be posting that. I'm not sure. He actually... I don't think he was on last time I was on with the shills, but anyway, I'm going to be on with the shills tomorrow night at 8 p.m. Eastern Time, so tune in for that too. It won't be on my channel, but it'll be on their channel. So, I'm not sure... I should probably figure that out real quick. I'm not sure exactly who's going to be there hosting it. But they were saying, yeah, the Shill Show... they didn't give me much more information than that, but I think we're going to probably be talking about some space denial stuff or something. I don't know. But yeah, I was invited on for another show with them for this Friday, so that's tomorrow night, 8 p.m. Eastern Time. So yeah, I'll be on with the shills tomorrow night. Heat Shield. Hope to see you there. Alright, well, I think that's going to do it for this webcast, and, yeah, where's my NASA check? Where's mine, too? It's in the mail. Yep. Alright, well, I'm going to wrap up this webcast, and thank you all for watching. So check back tomorrow for the stacked image, processed and cleaned up with flat field subtraction and calibration. And yeah, I think that does it. I think that puts a nice end cap on this object. I didn't know 5 years ago that I'd still be taking pictures of it now in 2020, but actually that worked out quite nice because now we got to see a little bit of proper motion there in a nearby star. So it served as a nice positive control for the image. We like to have all the proper controls for our experiments, right? So it worked out quite nice. I think this has been a perfect way to cap this off. Hopefully I won't have to dedicate yet more telescope time to this object after this point. I think we've done enough. Alright, I'm going to wrap it up. Thanks again, everyone, for watching. Clear skies, folks.